Hello everyone and welcome back to another episode of Math with Dr. War. In today's video, we're going to be applying the rules of exponents in numerical expressions, and by that we will be using whole numbers or integers as the base. Now on the task test they would use variables. On the GED test it seems like they're going to be using their base as a numeral, so I think that's fine. And also I think on the GED test they won't be using these weird word problems you saw on the task exam. I have plenty videos on the laws of exponents, so I will link some of them below, but you can search and I will create a playlist which just says the laws of exponents for anyone who wants to have a much slower pace looking at each law. But because I've did so many videos, I'm just going to be doing like an overview of the laws of exponents, and then we'll look at some sample questions. Now the first law we're going to look at is, now I'm going to be saying law and rule, so I'll be going back and forth. So the first one we're going to look at is the product rule. And the product rule, and we all know product means to multiply. The product rule basically states that if your bases match, you always keep your base and you're going to add the exponents. So this will be m plus n. So an example of this, and I'm going to go here, is suppose you have 2 to the 4th power and you're multiplying by 2 to the 6th power. Now because my bases match, and you can only multiply when your bases match, you keep your base and you would add your exponents. 4 plus 6, so this will be 2 to the 10th power. Please remember that on your test you can be given whole numbers or you can be given integers. So you must be able to add your integers. So for example, suppose you have 3 to the negative 2 and you're multiplying by a matching base of 3, which is raised to the 5th power. So once they match, you keep your base, and we're going to have to add negative 2 plus 5. And remember, when you're adding your integers and the signs are different, you subtract. So you're like, oh, 5 minus 2 is 3, and you keep the sign of the larger number. My larger number is 5, which is a positive, so my 3 here will be a positive. Next, I have the power rule. And the power rule states that if you have a base raised to an exponent and raised to another exponent, you will, and I'm going to change my color, you will keep your base and you would multiply your exponents. So m multiplied by n. So suppose you have, let's say, 4 raised to the 3rd power, and then that is raised to the 5th power. So you would keep your base, but because you have a base raised to a power and then raised to another power, you would multiply your exponents. So this would be 3 times 5. So this will be 4 to the 15th power. I don't care what your base is. It could be 7 to the 2nd power, and then that is raised to the 9th power. You keep your base and you would multiply 2 times 9, and that would give you 7. 2 times 9, 18th power. Next, we have the quotient rule. Now, quotient means to divide. So whenever you're dividing and your bases match, you would keep your base, but you would subtract your exponent, m minus n. If you have 10 to the 12th power divided by 10 to the 4th power, once it's a division, you keep your base and you would subtract 12 minus 4, and this would give us 10, and 12 minus 4 is to the 8th power. There's 2 other additional rules. We have the negative rule. Now, negative rule is very important. The negative rule is we do not like negative exponents. So whenever I see a negative exponent, you have to write it in the reciprocal, which is writing as a fraction. So you have 1 over a, and then your exponent become positive. So by the reciprocal, if I wrote this as a fraction, I would have to put it over 1, and basically I just flipped it around. Suppose I have, let's say, 6 to the negative 3. To write that in the positive, it would be 1 over 6, and then the 3 becomes positive. Now, where would you see the negative rule is, remember, we have the product, the power, and the quotient. So I'm going to give you an example of the product. So let's write product here. So suppose I says, okay, I have 6 to the third power, and I'm multiplying by 6 to the negative 7. My bases match, so I would keep my base. I'm going to add my exponents, 3 plus negative 7. I notice my signs are different, so using my rules for integers, I keep my base, and once the signs are different, I subtract, which will be 4, and I keep the sign of the larger. So now that's to the negative 4. But again, you're like, oh, negative exponents are not allowed. Whenever I see a negative exponent, I think of a fraction. So I'm like, okay, I have to write that as a fraction. So this would now be 1 over 6 to the positive 4. So that's an example of if it was the product rule. Suppose it was the power rule. So for the power rule, you could have 2 raised to the 4th power, and then I could say, oh, raise that to the negative 5. So I have 2 raised to the power, raised to another power. I have to multiply, so this will be 2 times negative 5. Now, my rules for multiplication of integers is a positive times a negative would give me a negative. And 2 times 5 is 10. So my answer will be 2 raised to the negative 10. But again, that exponent is a negative. So to write it in the positive, I'm going to have to make a fraction, which means I'm going to have 1 over 2, and then that's raised to a positive 10. And the quotient, because we are dividing, so if you have the quotient, suppose we have 7 to the 3rd power, and I have to divide by 7 to the 8th power. So the bases match, I keep, but I'm going to have to subtract the exponent because I'm dividing. So that is 3 minus 8. So I have to remember my rule for subtracting integers. The rule is you keep the first, you change the subtraction sign to the opposite, which will be a plus. Your second integer, you change to the opposite, so this is a positive 8, so it now becomes negative 8. Now that I'm adding, I notice that my signs are different, which means I actually have to subtract them. So you're like 8 minus 3 is 5, and I keep the sign of the bigger number. So that's a negative 5. And again, no negative exponents are allowed. So when I write that as the positive, by writing it as the reciprocal, it is 1 over 7 to the 5th power. And the very last rule is the 0 rule. And it basically states any base raised to the 0 power is a 1. So I don't care what you have. You could have, let's say, 5 to the 0 power, your answer is 1. 10 to the 0 power, your answer is 1. You could have 150 to the 0 power, your answer is 1. So these are your laws of exponents: product rule, power rule, quotient rule, negative rule, and 0 rule. The 3 you have to know the operations for is the product rule. Remember, if the bases match, you add your exponents. The power rule, again, you have a base raised to an exponent, raised to another exponent, you multiply. Quotient rule means we're dividing, and if those bases match, you keep that base and you subtract. If your answer turns out to be a negative exponent, because again, you could be given integers, remember to write it in the positive as the reciprocal. And if you have the 0 exponent, remember that answer is a 1. So let's look at some sample problems, and I'm going to number them. It says which expression is equivalent to 3 to the second times 4 to the second times 3 to the fourth. So we're multiplying. So the rule for multiplication states that your bases must match. So who's matching here? 3 and 3. So 3 to the second will multiply 3 to the fourth. And because you're multiplying, the rule states you keep your base and you're going to add 2 plus 4. So that will be 3 to the 6. Now our little friend here, which is the 4 to the second, does not have a partner. So we're just going to keep that as times 4 to the second. Remember, in order to multiply, your bases must match. If they do not match, you cannot multiply. Therefore, our answer is A. Let's look at number 2. Which of the following is equivalent to 7 to the negative 6 times 7 to the 4? So again, we're multiplying. The bases match, so I keep my base. I'm going to add the exponents. It's negative 6 plus 4. I notice that they're different. One is negative and one is positive. And the rule says that when you're adding and the signs are different, you subtract. So I get a 2. I look to see who's the bigger number. It's a 6. So I see a negative 2. Now here's the thing. Sometimes these exams do not follow the rules. So I get a negative 2. I'm going to look into my answer choices. I see a negative 2. My answer is C. I did not have to change it to the positive form. And sometimes that happens. Always when you get a negative exponent, look at the answer choices to see if it's there. If it's there, choose it. If it's not, that's when you would have to change it to the reciprocal, which would be 1 over 7 to the second power. Let's look at number 3. Now here, all I see is 3 to the 8th power and then raised to the second power. So this is my power rule. And I know that with the power rule, you keep your base and we would have to multiply 8 times 2. So that would be 3 to the 16th. So my answer is D. Number 4, which expression is equivalent to 9 raised to the negative 2 and then raised to the 8th? So I know, again, this is my power rule. So I would keep my 9. I would multiply negative 2 times 8. Now, remember, when you're multiplying integers and the signs are different, your answer will be a negative, and 2 times 8 is 16. So I know my base has to be 9. So if you were on the test and you could not remember your answers, you have to remember, you will or should remember part of the rule, and your base must match. So I could get rid of A and I could get rid of D. Now, there's some students that they see the negative 16 and they look in their answer choices. They don't see a negative 16, but they do see a 16. So they're like, oh, my answer is B, which is technically correct. But remember, the reason your answer is B, we don't like negative exponents. So to write it in the positive, we have to use the negative rule, which is making the reciprocal. 1, 9, and that's raised to the positive 16. Question 5, here we have the quotient rule, and the quotient rule means you're dividing, and if your bases match, you keep your base and you're going to subtract. So this will be 10 minus 2, and this will be 3 to the 8th power. So again, if you were on the GED examination, remember your bases must stay the same. So your answer is not A and it's not B. Remember, you subtract the exponents and your answer is D. Question 6, which value is equivalent to 10 to the 8 divided by 10 to the 6? So this will be 10, and then you would subtract, and you get 10 to the second, and you look at the answers and you don't see it. Now, when your exponent is pretty small, sometimes they change their answer to a numerical answer. 10 to the second means 10 multiplying itself twice. 10 times 10 is 100. So your answer is A. Now, let's get into question 7, where sometimes they want you to do some critical thinking. It says, which expression is equivalent to 3 to the 8th? And then when you look at your answer choices, you have to do some work. A is the power rule. You have a base raised to an exponent raised to another exponent. So you're like, oh, that's when I multiply. And 4 times 4 is 16. So this is 3 to the 16. That is not 3 to the 8th. Your answer is not A. When you move over to the B, you see 3 to the second times 3 to the second, and then all of that is raised to the 4th. The best thing about this is that what's inside the parentheses match. Their base are both 3. So you would keep that base and you would add 2 plus 2 is 4, right? And then you have the 4 on the outside. So basically, this is the power rule, and we just did that with A and figured out it was 16. So your answer is not B. We go to C and we notice that it's a multiplication, and when you're multiplying, you keep the base and you add the exponents, 2 plus 2 plus 2. But when we add all those 2's, you're going to get 6. 2 plus 2 is 4, and 4 plus 2 is 6. So that is not 8. So your answer is D, and I would suggest not even doing the work. But if I did the work, this is the power rule, so I would multiply. So this would be 3 to the 4th times 2 times 2, 3 to the 4th. Again, when you're multiplying and the bases match, you keep that base, and 4 plus 4 is 8. But again, we didn't need to do that because we eliminated A, B, and C, so your answer can only be D. Question 8. Which of the following is equivalent to the expression shown below? So for question 8, notice you have a multiplication and then a division. So let's multiply first. They're matching, so let's keep the 2. We're going to have to add. 4 plus 7 is 11. And finally, let's divide. Bases match, so you keep your base. And what do? We subtract when we're dividing. 11 minus 6 is 2 to the 5th power. So your answer is D. So that wasn't so difficult. Now we come to the last and final question, number 9. And it says simplify, and you have 2 to the 9th times 3 to the 5th. Now notice the bases don't match, so you can't multiply. Times, and then in the parentheses here we have 2 to the 4th times 3. Again, they don't match, so you can't multiply. However, on the outside, there's an exponent of 2. So this 2 here will have to be distributed to everyone in the parentheses. So we have 2 to the 9th times 3 to the 5th times 2 to the 4th times 3 raised to the 2nd. We're going to do this first. 2 to the 4th, that will get an exponent of 2 on the outside. And the 3 would get an exponent of 2 on the outside. Now, this now becomes the power rule, which means we're going to have to multiply. This becomes 2 raised to the 8th power times. Now here, you notice that there's no exponent there, but there is an invisible one. So if you have a base that does not have an exponent, there is an invisible one there. Just write it in. Many of my students do. And because it's the power rule, you would multiply, and 1 times 2 is 2. So that's 3 to the 2nd. And remember, we had the 2 to the 9th times 3 to the 5th. Now, because we're multiplying, you can drop all the parentheses, and you get 2 to the 9th times 3 to the 5th times 2 to the 8th times 3 to the 2nd. And the product rule basically states that you can only multiply if your bases match. So the 2 to the 9th can multiply the 2 to the 8th, and the 3 to the 5th can multiply the 3 to the 2nd. So because these match, you keep your base, and we're going to add 9 and 8, which gives us 17. Now remember, your test is timed. So I get the 17, I go to my answer choices, I see the 17, so my answer is the last one. You can continue times these match, so you keep your 3, you're going to have to add the 5 and the 2, which gives you 7. So the 3 is raised to the 7th power. I hope this was helpful. Again, if you like the content, please like, subscribe, share with anyone, and also drop a comment. Again, good luck on your GED exam, and until our next video. And remember, you can't use a calculator on this section, so please make sure that you can add, subtract, and multiply your integers. Good luck.